I'm Olivier Bloch. I'm part of the Azure IoT team. Thanks for coming. It's been a long week for you guys, and that's the last day today. It is, right? No? It's tomorrow? Nice. Still, it's 12:30, it's siesta time, so let's try and make that session interactive. Don't hesitate to stop me when you have questions, and eventually come to the mic, or I will actually repeat your questions. So like just raise a hand if there's something that really you're just like, yeah, what is he talking about? The session today is about an introduction to getting started with Azure IoT development. How many of you are developers? Yay. How many of you have been doing C development? How many of you claim they are embedded developers, like device developers? That's fine, that's okay. I'm part of that team that deals with the SDKs for Azure IoT. And you'll see where that fits in the bigger picture in the presentation. My objective is to kind of demystify the device development and how to use IoT in general, so forth, and put it at a level that everyone understands. We'll have some demos, and I really want to have you also interact on these questions. I really insist on that. I don't have any goodies for you to give away, whatever, but still, questions are very welcome. What I will be covering is an intro of what Azure IoT Hub is about in the context of Azure and in the context of Azure IoT. And the reason why is because I'm gonna basically roam around IoT Hub when it comes to developer experience. Lots of things basically are around IoT Hub. I will tell you what are the ABC, like step 1, creating an IoT Hub, step 2, doing that. So that way, when you go back after the session, like don't go to any other session, doesn't matter. Just go get your laptop and start coding for IoT Hub, right? So that way you'll get started really rapidly. So the first thing I'm gonna walk you through is like that creation of an hub instance. We'll talk about what we call the device registry, which is very important when you're a developer when it comes to managing these devices from the cloud. And then we'll connect some devices, whether they're simulated or real ones. I have a little tiny device here. We're going to try and connect to Azure. We're going to try and do some fun things with it. Some will be live, and the rest will be live. So a little prayer for the demo gods, and let's pray for that to work. Once the devices are connected, we'll talk about the type of data we're sending, how we're receiving it, how we're consuming it on the back end. And then we'll show you a couple of fun scenarios of actual solution running on this device. How many of you have been working on an Azure IoT solution already? Get out. No, just kidding. Stay here. So Azure IoT, for the other ones, addresses the need that customers have to implement IoT solutions, Internet of Things solutions. Everyone has its own definition. But when it comes to what we perceive as Microsoft is IoT, what we have in mind is things, insights that are actually determined outside from the devices and from the things data, and then actions. So basically, the things, whether they're devices or a data source somewhere, generate data. That data needs to be analyzed to get insights, and you need to do something out of that. Having devices connected to just send their data and visualize it somewhere, it's okay, but it's not exactly what you would expect of an IoT solution. An IoT solution will actually consist in safely and securely connecting devices and things, collecting the data, and then implementing a chain of events or a chain of services that will take care of that data and do whatever you need it to do. So that's an example here of what an IoT solution could look like. That's the new pre-configured solution we have in IoT Suite. And it has an IoT Hub to connect the devices and talk to them. It has microservices that actually you can configure at will to display a dashboard and so forth. There's like Cosmos DB to store that data if you want to analyze it later. We're using Active Directory to do user login into the mechanisms. And then we have Logic Apps on the other hand, so that we can trigger a line of business workflow in Dynamics or something like that behind that. So imagine devices do something like they are, for example, vending machine. They have temperature sensors, and they're giving that temperature up to IoT Hub, and then you have a machine learning algorithm that detects anomaly on the feed of data, and then you can predict when you need to send someone to do maintenance on that machine, create the ticket automatically, and then the maintenance guy knows where to go, when to go, and what kind of parts to bring with them. Does it make sense? So that's what an IT solution is about. IoT Hub is very important because basically that's the gateway for the devices, the source of data, right? And that's also the service, which is a PaaS service on Azure that will allow you to manage these devices, to know they're connected or not, to know if they are authorized to connect to the rest of the system. And you will see how we do that. But before, I want to show you at a high level how IoT Hub can be used. The first and logical thing is connect a device that can communicate over TCP and that can load a SSL stack because we want to encrypt the data. These devices will communicate directly eventually with IoT Hub, which is in the cloud, right? So the device has an IP address and can address with specific credential it has, can address IoT Hub directly. For that, we're supporting several protocols. I listed them here. We can talk about them at the end. That's like a 3 hours discussion, which protocol does what not. I don't want to be there, because actually what IoT Hub does, it provides a level of abstraction for what's happening at the protocol level. It gives rich telemetry, rich features that you want to leverage and use, rather than stay at the protocol level and doing MQTT and sending to a topic or whatever. Here you're just one level above, and you can already implement tons of things. And, well, if you have protocol requirements, then you can use one of these ones, like AMQP, MQTT, and HTTP. Some of these devices that are out there cannot talk directly to the IoT Hub because they eventually use a field bus. They don't have an IP address, and very often what we use is what we call a field gateway, which is that box that devices talk to in whatever language, protocol, field bus they want, and the field gateway itself will act as a relay up to the cloud. Then you also have devices that can connect to IP, but that you don't want to implement one of these protocols or use our SDKs. If you don't want to do that, no problem. We have an example of what we call a cloud gateway that you can use to create your own translation gateway, if you will. That will be sitting in the cloud, and it will be running some code that receives the messages the way you want, or the way you already implemented your communication from devices to the cloud, and then interact with IoT Hub. Now we're getting a bit more complex. Same principle, but with a field gateway that doesn't talk one of the protocols that we support. You can still use the cloud gateway up in the cloud to translate that. So once you've done that, you have your source of data. What you need to think about is interacting with the IoT Hub on the other side. Manage these devices, allow them to connect, remove them, like kind of decommission devices, send commands to unique devices. Eventually that app will be in the cloud, or that could be a management application on a laptop, on a terminal or something. The other thing you're going to do as a developer is hook up that data into other Azure services. And here, like, possibilities are endless. Anything that runs in Azure, you can actually send the data to, whether it's like storage, or is it like real-time analytics, or is it time series insight. You can actually just do it. And as a developer, you will want to do the deployment using ARM templates and Azure SDKs and so forth. And then on top of that, you're going to have your applications, companion apps, dashboards, controllers, whatever. So you see, everything revolves around IoT Hub. I will not dive too much into detail about how do you code for Azure Function or Streamlytics, because this is a different topic. Let's go back to the IoT topic. My team is looking after making your life as a developer easier. Tools, SDKs. So what we want to provide is a set of SDKs that run on devices or on backend applications, or provide samples for the cloud gateway so that you can just pick and use. Let's dive a bit more closer into what IoT Hub is about and what you're going to have to do. The first thing, this is a PaaS service. This is a resource in Azure. So basically, through the Azure resource management, you're going to have to instantiate IoT Hub as a service. The second thing you're going to have to interact with is called device registry. So that's the primary interface of IoT Hub for managing devices, creating these device identities that I'm going to talk about, and updating the credentials for devices, disabling a device from the cloud, and so forth. All of that offers an API that you can interact with in your applications. Once you have a device identity that is created for one device, you can connect a device to IoT Hub. The first type of thing you're going to do is what we call internally the device-to-cloud communication. So that's telemetry message, raw messaging. As you'll see, it's not so raw. The principle of the message is to leverage whatever the protocols offer to have the notion of properties in a header and then a body. In that body, you put whatever you want, right? There's a certain size, though. So we have a limit of 256 Ks of data in one message. Then what you could do is just basically do chunks of messages if you have some big data to send, and send several messages. And before someone asks and has already looked into, there's a notion of 4K per messages. That's for billing. So if you send a message that is like 16K big, it's one message, but it will be billed as 2 messages by Azure IoT. Okay? So that data is sent by devices up to the cloud. IoT Hub has it. It basically has, under the hood, an event hub with a 1-day retention policy by default that will keep the data of that device until it's consumed by a service. So that endpoint, that event hub endpoint, you can basically just attach a reader or another service to extract the data from the IoT Hub. And the data will stay there in that endpoint for 1 day. Or you can configure that retention policy to go beyond the 1 day. The other thing you can do is communicate to a device. Because devices are authenticated uniquely, they all have their own identity, then you can address these devices. You can send a raw message back, a cloud-to-device message. Same notion, property, load, and basically, you're in business. Beyond that endpoint, which is the Event Hub endpoint to receive data, we recently added the capability to add what we call custom endpoints. We realized that lots of customers and users were basically adding a Streamlabs job to send data to another service, like storage, like service bus message queues and topics. And so what we said, hey, let's actually, as part of the IoT Hub infrastructure and Portal Blade, let's allow people to create custom endpoints to point directly to a blob storage, to a message bus queue or topic, or to another event hub. Beyond the raw messaging that allows you to do already a lot of things, we are implementing what I call structured messaging. So we have an infrastructure that we call device twin that allows you to have a replica of the device state in the cloud. It's basically last known state that is synchronized using our SDKs and the IoT Hub. It's synchronized between the device and the cloud. And I'll give you some details about that. Last but not least, you have the notion of methods. While the cloud-to-device messaging is something that is raw, that you have to implement your logic for, hey, did the device respond, and what kind of response or whatnot, and that also has a notion of buffer of messages for each of the devices. So if the device is not online, that cloud-to-device message can stay in the pipe, up to 50 per device, and when the device connects, it just unpiles all the messages. But we know that sometimes you need to have an immediate response, and so we implemented device method, which is, think of it as a synchronous way of invoking code on a device. Like, device, I want you to shut down. And I want to know whether or not you're connected, and you responded to my call immediately. So think of it as it's really a wait async something, so you're waiting for the response from the device. And you can set up a little timeout, so there's limits. So that's basically your command goes down, device processes that, and sends a response immediately. So that's what we call methods. Once you've done that for one device, you can do that for millions of devices. So basically, like before you reach the limit, will be reach. So IoT Hub can really receive connections in parallel from millions of devices for each of the instances of IoT Hub. If you go towards like more than millions, then you can have several instances of IoT Hub deployed, and we'll get even richer. So go for it. But basically what I want to say with that is there's like virtually no limit to that because you can extend the capabilities of one instance of IoT Hub or multiply the number of IoT Hubs. Okay, so these are what I call the endpoints of IoT Hub. This is all you have to know on how things are working around it. So let's get started. First step is to create a hub. How many of you prefer command line? No. How many of you prefer the portal? Okay, we'll do both. So you can do that through the portal. You can use ARM templates. Right, super easy, because your IoT Hub can be part of a broader solution that you want to deploy at once and replicate on different subscriptions. So you can have actually IoT Hub as one of the resources. You can use the Azure CLI, which is command line interface. I'll try and demystify that for those who don't like CLI. It's pretty simple and straightforward. And eventually PowerShell. So let's see what it looks like. So the Azure CLI as an extension called IoT. And what you can do is basically create that, which is like create an IoT Hub. I will create that in a resource group called demos, and I will name it. And it's going to be number 2, because I want. Okay? So basically, the Azure CLI will already logged in, so it should be fine, unless it asks me to log again. And it will create that IoT Hub in the right resource group. So what I'm going to do is I'm going to bring up this resource group here, and while it's doing its job, I'm going to show you how to do the same thing from the portal. So basically, you create a new resource. You look for Internet of Things in there. Oh, well, actually, it's just one click away. And you have a set of services that actually are tagged as Internet of Things. The first one on top is IoT Hub. Select IoT Hub, and from here, you can put a name. It has to be unique. That's a public endpoint. And basically, it's going to be something.azuredevices.net. So you basically have a unique endpoint that you need to create here. You pick your subscription. We have the notion of partitions. I'll answer to the questions about that. We'll not give too much details right now. And the location. Location for the IoT Hub is pretty much everywhere. We also have sovereign cloud supports and government cloud supports for IoT Hub. And so you're covered. If you're not, I know the person to go annoy to get you IoT Hub in your region. Let's see if that IoT Hub has been created using the command line. I should have received something. It's still running. Get off the internet, people. Okay, we'll let it do its thing. We'll come back to it. So basically, yes, it's here. It's been created. IoT demo 2. Okay. So the portal actually will give you a bunch of information about the IoT Hub. You can track the activities. It will soon feed all its logging information into Azure Monitoring. So you'll be able to track what's going on in IoT Hub in terms of operations. You have a set of what we call shared access policies. These are the ones that are used for the backend applications, for the management side of things. Remember, we have IoT Hub device side of things, and then we have the backend side of things. To interact with IoT Hub, you need to have policies created to authenticate the clients. On the device side of things, well, we have what we call a Device Explorer, which is a UI to interact with the device registry. I'll get back to that. Oops, that's not the one, that's the one. Okay, so we have an IoT Hub. The next step, if I can get back control of my presentation, yes. The next step is actually working with devices, and that is to be done in a secure environment. You've heard about the hacks and things that through Internet of Things devices happen recently. And this is unfortunate. If you have a router from Cisco and your password is root admin, change it. I can see the guys are just like, hey, go change it. But that's what it is. Root admin is the default password for all the Cisco routers. Not anymore. They changed that since the DDoS attack like some time ago. Not so long ago. But until then, it was still like root admin. Incredible. So once you have a device ID, basically we authorize connectivity from devices that are authenticated, and we'll see there are several ways of authenticating, and that establish a communication over SSL, right? So we have encryption that is mandatory for a device to connect to IoT Hub. No way around. If you tell me, hey, I have a very tiny device, it cannot run an SSL stack, I'm going to tell you, well, then use a gateway, because that's not safe. You don't want your data from your factory floor to go up to the cloud, that anyone can read it. The other thing is the authentication is mutual. Because yes, you want to authenticate your device, but you also want to make sure your device sends the data to the right IoT hub, right? You want that to talk to your endpoint because then the data is yours, even if it goes to a public cloud. You own that data and you will store it somewhere securely on Azure and then you will use it. And on the device side of things, to establish that secure communications, well, this is not always super easy, so we have you covered. And on the device side of things, not only we cover Windows and Linux, but we also cover lots of real-time OSs, delivering C SDK, which is NC99C, very portable. No external dependencies beyond the SSL stacks. We have Java support, we have C#, which is .NET Standard 2, actually. We just bumped up to version 2 of .NET Standard, and Python. One thing that we recommend, and you will not see in the demo because I'm lame, and for demos it's more easy. But the credentials that the device will be provisioned with, that you need for authenticating it to IoT Hub, they need to be stored securely on the device. So we're working with TPM and we're working with other hardware, safe hardware manufacturers to make sure that we have support for their various chips by default. We're also working closely with Microsoft Research on other technologies. And basically, the recommendation is if you have credentials, you store them into that TPM or safe storage, and no one sees it. Not even the code in your client on your device should not see it. It should get a token, like a public key, that can be used to authenticate the device, not the private key or the cert or the cert thumbprint. Make sense? I hope it does. So the main authentication methods we have for devices is the notion of device ID and private key, that whether on the device or somewhere else, you generate a SAS token, and that's the SAS token used to authenticate the device. So your private key typically could be stored into a TPM, and you generate the SAS token directly in the TPM that has a capability. So basically, you never see the actual private key in your code. You just get the SAS token. It has an expiry time. Recommendation is to make it low. It's better to regenerate the SAS token than to have a SAS token that is valid for 1 year. Don't do that. And then this device will actually use that token to authenticate with IoT Hub. Okay? The other way is X509 certs. So mutual identification, authentication of both the service and the client using certs, whether self-signed, whether CA signed. Okay? So basically, you can pick the type of certificate you want. And the reason why we give that flexibility and don't enforce one is because in the device world, not all devices are equal. Not all of them have the same level of support for that or that security or that encryption. And so we need to offer some choices there for the users. The device identities in the registry are unique, right? So this is like very important as well. In the context of one IoT hub, you cannot have two devices with the same identity. The credentials are unique. You don't share a key. There's actually, clients will be allowed to communicate with IoT Hub if you use one of the access policies that I talked about at the beginning. There's one that I call God mode, which is the IoT Hub owner credentials that can do whatever he wants. He can impersonate a device. Don't do that, even for demos or proof of concept. That's not a good idea. The thing also is that you cannot have two devices coming with the same identity and credentials connecting to IoT Hub. IoT Hub will just drop the connection existing, and if we authenticate a new device, it will accept that connection. Device twin is also managed by that device identity management. I'll dive into the device twin just after. So that device identity, once it's been created, you basically have a reference for your device in the cloud that can be interacted with. All of that is done from the back end, as in you create these device identities, you do provisioning of this device in numbers. And so we offer several options to do that, whether you interact manually using Azure CLI, there's an extension for Visual Studio Code, whether using the portal, or using one of our client SDKs for the service side of things. So we have client SDKs for .NET, Node, Java, and Python. So if you want to have your own device management and backend application that creates 10 device identities because you're deploying 10 new devices, you can automate that into your application. So let's do and create some device identities. And this is where it actually becomes really disappointing because it's as easy as clicking plus add. New device, picking the type of authentication, and save. So I have a device identity that's just been created. I'll be able to use it later on to connect devices using the credentials. So the device itself comes with the primary key, secondary key, and connection string, primary, secondary. If you're fast enough, you can read. If you're not, too bad, you cannot hack my demo. I'll be back to that. So that's the first way. Another way of creating device identities is basically using Azure CLI again. So I'm going to use this time not the hub extension, but the device. And I'm going to create a new device identity. I'm going to use the hub name, which was Ignite Demo IoT Hub 2, right? And this one is new device 2, for example. We're creating that new device identity in command line. Device appears here, it's magic. If I didn't mess up, yes, there you go. So you see, pretty straightforward. You can do the same thing in code. We have samples in all our SDKs for you to do that in your code. Copy, paste of the code, off you go. I'm telling you, the demos are not super fun. They're super simple, but that's the idea. It's simple to work with Azure IoT Hub. So here's the thing, though. People will start asking, especially those who never worked with devices or starting working with devices. So it's all good. I'm one person, and I can provision devices into my IoT Hub. But what if I have more than one device? What if I need to create that many device identities that all, at the end of the day, will not have a fancy name like new device, but will have a GUID or something like a serial number as a device identity? As a human, it will become hard to do. And actually, even our portal will not allow you to see and visualize more than 1,000 device identity at a time. So basically, even the portal is useless for that. So you need applications. But actually, this is also not viable when it comes to getting these identities on the devices themselves. So basically, you're at a loss here. What's going on? And here is why we developed and recently published the device provisioning service. Because having an identity for a device, having credentials, having the private key, having the search sum print, it's good. How do you put it on your device? In factory, each device was a unique identifier in there. It doesn't work. If you create 10 devices, you can still do that manually. If you create millions, you cannot flash them on the factory floor. So what DPS does, it allows you to leverage one of these unique identifiers that the hardware manufacturer is already using. Is it a MAC address? Is it a serial number? Is it something, a seed that is hidden somewhere with a one-time use only, whatever? So that's something that is unique on each of the devices. As the user, you will be able to associate each of these unique identities with an IoT Hub of yours. So basically, you indicate to the DPS service that, hey, these devices that will come claiming they are blah, they're fine connecting to my IoT Hub, which is here. So when the device comes online, It will run a piece of code that we provide that you can implement in your device that is a client for the DPS service. It will connect to DPS. So basically, it's a global endpoint for all devices. It will provide, obviously, it's encrypted over SSL once again, so you have to have this encryption. It will say, I am device Lambda, and I want to connect. DPS makes the correlation in the lookup table and will create the device identity for you in your IoT Hub. Eventually, you can also force the creation ahead of time if you want. If you don't want DPS to do that for you, but it's easier to do it with DPS. DPS retrieves the credentials, pass them over to the device, right? Encrypted. The device usually will store them. Not usually, actually. Our Bootstrap is hooked up directly into a TPM. We have DICE support. We have various types of safe storage support already. We just had our team developing one for ST Safe. And so basically, store the credentials immediately down there in the safe storage of the device. Then the device code will take over, and we have the IoT Hub client that gets the credentials. So in that case, the SAS token or the right thumbprint that it needs to communicate establishes a connection with the IoT Hub and then communicates. Make sense? So we had a full session about DPS yesterday. You can see the recording online. I think it's already been published. That's BRK3215. Okay, now we have devices connected safely, or actually not yet connected. They are identifiable. And once you have that connection has been established over SSL, you can start communicating using the D2C endpoint, and you can talk back using the service SDKs to the devices. So let me show you rapidly how that looks like. In order to do that, what I will do is I'm going to go here, and I'm going to copy the connection string here. Once again, this is not the way you want to do that in real life. I'm going to use the connection string directly into a sample that we have as part of our SDKs. Oops, hello, where are you? Here, sorry. So this is the repository for our Azure IoT SDK for Node. Pretty straightforward for doing demos and practical. And you will see in that repository that we have several sections. The ones that you care about are service and device. In the device folder, you have all the code for the device clients. We offer them as an NPM package. For other languages, we offer them as a NuGet package, as a Maven package, as an apt-get package. So basically, you don't have to compile every time. You can definitely leverage one of the binary versions. And in device, we have a bunch of samples. And basically, all the basics. Think of them as the hello word for each of the features that we have. Let me go into device. Oops, sorry. And samples. And from here, I'm going to start the simple sample device. And I will use the connection string, which is this one. But I need to put some quotes here. So basically, what I'm doing here is starting a client. And before I do that, I will show you what the sample is. Simple sample device here. It leverages the packages. It will create a client from the connection string. So that would have been something like maybe using directly the SAS token once we have the safe storage support. It connects callbacks for when a message is received from the cloud. And in our demo, it sets an interval for sending fake data, because that's Node. It doesn't have sensor right now. And it will send wind speed, temperature, humidity in the form of a message. And we'll do a send event, which is that one API I need to call. So the SDK is like, create me, attach callbacks or messages coming in, send a message. That's what the SDK does for you. Abstracts the authentication, abstracts the complexity of the protocols underneath, allows you to leverage the protocol features such as keep alive messages to keep the TCP connection up so that the device can be addressed when you need it. The SDK makes your life super simple for that matter. So now I'm going to just start the device here, and it's going to connect, and it's going to send data. No, okay. That's fine. So right now, eventually, what I want to do is show you the output. We have a great tool within VS Code, which is an extension called the Azure IoT Toolkit. That extension has some functionality that I want to use. One of them is monitoring D2C messages. But because I created a new IoT Hub, I need to connect that tool to that new IoT Hub. And for that, I will go back to my IoT Hub itself. These are operations you might have to do. I will pick the God mode code, like connection string, and I will go back to my tool, and I will tell it to set up, go away. I'm on the right one here, this is node. Let's do that. And set IoT Hub connection string, paste, enter. Okay, so I've updated the connection string, and I can use the tool within VS Code to start monitoring device-to-cloud messages. So that application, VS Code, connects to IoT Hub as a monitoring application, and I can see the messages coming from the device in the cloud. I know, it all happens on my laptop, so you don't believe me, but yes, it goes through the cloud, I promise. We'll play with that a bit more. So that's one way of reading the data. Obviously, I mentioned you can actually read the data from an application on the back end. Let me stop the monitoring here and talk a bit more about what kind of data you can have going through IoT Hub. So telemetry is one kind of data. But telemetry is raw data, right? So you can use JSON. You can actually also do something some customers do. They want to compress the data that they want to send. So using raw messaging is great for them. We don't want to remove that. We want to provide customers a way to do whatever they want in there. But then, if they want to do simple configuration, poking on the device to know what the state is and so on, we have the notion of device twins. So device twin is basically a JSON file that IoT Hub maintains for each of the device identities being created. That device twin, I'll detail that, basically stores the last known state of the device. The device connects to IoT Hub. At that moment, it synchronizes the device twin. And then when there are changes on one side or the other, both the SDK and the IoT Hub will actually take care of the synchronization if there is connectivity. If there's no connectivity, you work on one side, it keeps the last known state. You work on the other side, it works on the last known desired state, I would say. When the device comes online, we synchronize that JSON file. As you'll see, there cannot be any conflict because they don't touch the same parts of the JSON file. Another thing that it allows you to do, we have the notion of tags on the twins. They allow you to group your devices. So you can create many tags and say, maybe a tag is called location. And remember, it's JSON, so location. And then in location, you have building, building number, level, room. And so now your devices, you can address them from the back end using these tags. You'll see that you can work with device twins with what we call jobs and queries. I'll get to that in a minute. But device twins is what you need to configure device and to manage them as a group. Device methods is that other type of structure data transfer that allows you to invoke a method on a device. Think about RPC, remote procedure call. So you have a call like if you're doing like a function in your code, but happens actually on the device remotely through IoT Hub, seamlessly. So that device twin that is managed by IoT Hub has properties and tags. The tags are owned by the cloud, never seen by the device, right? You don't need the device to know in which building it is. IoT Hub knows that for you, which is perfect because if you take the device and bring it in another room, you can have the backend say, hey, you know what? I moved the device from another room. Now, if you want to have automatic location, you can implement that using what we'll see as the reported properties. So then within the properties, you have two areas. There's the desired properties. They're basically owned by the cloud and read-only in the device side of things. This is, hey, device, I want you to be in that state. So I want you to run firmware number blah. I want the temperature in the room to be 75 degrees. These are states that properties you want your device to be in. You desire it to, and you ask nicely and politely. Reported properties are the things that the device says it is in. That's my state, right? And basically, it's owned by the device, read-only by the backend. Okay? So people ask, what about retention? Can I actually go in history with the twin? Short answer is no. IoT Hub and the device twin is about last known state. It's about instant, manipulation of that last known state, and it's about last known desired property. If you want to have history, you need to get the twin on the back end and store it somewhere, which is doable, but that's not the principle of it. If you want to have something that bufferizes messages, we have telemetry for that. So basically, don't use twins for telemetry, because you lose the notion of the timestamp and things like that. That make sense? And obviously, think about us in the back end. These are JSON files in a database. If you start poking from millions of devices every second this device twin, we're going to choke. So basically, we don't allow that. We basically throttle very early so that you don't try and do telemetry over the device twin. Method, you have a piece of code running on the device supported by the SDK. You implement your own code there. You invoke from the backend. So I was saying that, hey, when you have one twin, one device, okay. When you have a lot of twins, then you have the tags in the twin that allow you to address them using queries. So you can query across the device twin state. You can query across the tag, sorry. And then you can really leverage that in terms of displaying the data in a nice UI for, hey, I want to see that building, these devices, but then this room only. And it can very much filter all that data through the twin tags. And the jobs, that's a feature of IoT Hub that allows you to schedule things on the devices. You can prepare a series of manipulations of twins and methods in order to implement what we call device management, for example. A perfect example is the firmware update. That's something you might want to do on your device over the air. So the device is connected to IoT Hub. It has a device twin indicating what the actual firmware version is. On the back end, you see that the version is not the right one. And so you say, hey, device, I want you to be in that new version of the firmware. So in the desired property, you indicate firmware version number, new version. The code in your device that you implement, right, receive that notification from the SDK telling it, hey, there's a new desired property for you. What do you want to do with that? In your code, what you're going to do is say, depending on the way you implement your firmware updates, you will say, hey, I need to get a new firmware. It happens so that eventually you put the URI for that new firmware in that desired state next to the new firmware number. Then the device code can say, okay, I'm going to download that firmware. Eventually, in between, it will report a state saying downloading the firmware. On your back end, you receive notification there's a new reported property. And you know that the device is actually downloading that firmware. When the device is finished downloading, it can update the reported property and say downloaded, and the backend sees that. And from there, you can say, OK, deploy now. You invoke a method so that you know the device is responding instantly. You say now, because usually you don't want to update the firmware of an HVAC during the day or even worse, a robot arm that is in production, so you basically want to have a manual interaction. So you use methods for that, and you basically invoke that firmware update. Device updates the firmwares, reboots. When it reboots, indicates in the reported property the new version of the firmware. In the back end, you're all happy, everything is green, everything works. So you see, there's a set of interaction with device twin on both sides, and so you basically can package that as a job, and then you can schedule the job to be implemented on a group of devices. So that's the way we propose doing device management. And customers basically implement their own logic on top of that infrastructure, what I like to call the plumbing. So let's see how that looks like real quick. We'll use another sample of the Node SDK, which is this one here. And you can see here in my Device Explorer extension, I can see the device that is connected because it's still sending data. I'm going to stop it. And after some time, this will become green again, blue again, as in disconnected. So you see, you have the instant notion of a device that is connected and sending data, right? In that device twin sample, and I picked Node because it simplifies things when it comes to manipulating JSON. And so basically, you have the notion of creating the client again. So I'm creating this client from a connection string again. I'm opening the client. I'm getting the twin. So you have an API from the client to just get the twin That's the first thing you do when you start your device. And so basically, you look at what the various reported properties are or desired properties are to do something with them, okay? And eventually, I can play around with this. I don't want right now. What I want to do is just like show you at a high level and rapidly. You can play with that. And then you have the notion of the desired properties events. So when there's a new desired property that arrives, you can actually trigger events, and you can actually filter which properties you want what event to be triggered on. So it's pretty straightforward. On the properties desired climate change, I want to do something, right? And then basically you have various samples of that. I want to go all the way down to where actually we're sending the reported properties, which is here. And so the other way around is reporting these properties. Was in that case a firmware version, which is that one. So when I look at the actual device twin that's been created by default, I can use this tool here in VS Code to visualize the twin. So you can see here, desired properties is only metadata that allows you to know when it's been updated, and there's nothing in reported property right now, okay? Let me go in here and basically say, let's start this other sample, which is a device twin sample, using the same device ID. And basically it was creating the twin, it received a new desired property, and it reported a new state. If I look at what's going on that side, I should have the twin has been updated in the back end, so I have the reported property from the device, and the desired property has been taken into account by the device. Oh, actually not yet. I've not set a desired property. Let's do that. Let's go to Willow's Python. Come on, go ahead. You guys are shy. They're just like, I'm not sure. Do I? OK, so here, what I will do real quick is send a new desired property. And for that, there's a sample which is over here in service, and it's called device twin sample in Python. It requires a connection string in there. If I do that, let me try that real quick. That's live. I've not tested that yet. But I have trust in my dev team. And that's this guy here. Oh, sorry. No one is helping me. Thank you, guys. Samples and Python. Because I think it's going to ask me for the credentials if they're not in there. IoT Hub, device twin sample. Yes, so basically I can pass the connection string. So the connection string itself will be the IoT Hub connection string, because I'm managing that device. I use the God mode one. Don't do that. And paste. And then I need to inject a device name. It might require the, that's fine, we'll see. The quotes, yes. And there you go. So that time, we are actually setting a new desired property for the device. And on this other guy here, basically we received a new desired property, and we should have it retrieved, and we'll see that actually when I visualize this twin again, I will have the desired property has been set. Get device twin. And here I have a desired property, which is telemetry intervals 120, and this guy will have to change the way it's sending telemetry. So this is like basic samples of like manipulating device twin. When you get into these samples, you will see it's all commented, it's all pretty straightforward. Let me show you an actual example of what can be done with that, because I think that's even better. So I have a device right here. I'm going to show the device. Let me open another example, which is this guy here. And this one actually is C code running with the Arduino extension for VS Code. And I have my little device over here. Let me see if I can share it with you guys. Showing the camera here. So I have this little device here. It is ready to be flashed. On my configuration here, what I'm going to do is basically a build. That should work. If that doesn't, then I'm in trouble. And it will deploy onto that device a new sketch that is meant to report through twins the state of the various sensors. And for that, it leverages a web page to visualize it. So let's actually open that web page. It's going to be this one. It's going to ask me for a function name. We're using Azure function to give the state, the twin data into my UI here, E5D, I think that's the name of the function. So we have IoT Hub, Azure function gets the twin and makes it available to the web page for it to display. And when the device is coming online and connecting, it's connected, and the web page should refresh and get all the device state. So here we see the Wi-Fi information. We see that the sensors are in a good shape. We see the infrared is in good shape as well. So basically, we have the actual state of the device through device twin that in the back end I can monitor. This is a basic example. We're going to release that. I think they're planning to release that Saturday. So you can play around with that if you have the chance of having one of those little boards. Otherwise, you can reuse the exact same sample with your own hardware. So you get an idea of what device twin can do for you. Let me continue a little bit across what can be done. Because now we're able to send data. We're able to work on that configuration for that device. One thing that lots of customers have been asking for and doing is basically routing of the messages. When you send telemetry data, sometimes, or always actually, you want to filter that data because you're interested only in part of it. Or you want to send it in different paths. So the typical paths will be what we call hot, warm, and cold path. Cold path typically is just send data to storage somewhere so that it can be analyzed later. Warm path is something in the middle where you can have some delay, do some analytics, and that's fine. And hot path is when you want to have the chop-chop response from the analytics job that says, hey, we just reached that temperature, trigger something. And so in order to simplify your life, I mentioned the custom endpoints so that you don't have to implement always the same solution with stream analytics job, extracting data from IoT Hub and doing the rules. We basically brought that logic back into IoT Hub, allowing you to filter messages based on several things. And then you can send them to Event Hub, send them to Service Bus Topics, Service Bus Queues, and Storage Blob. The message itself will have to contain a body, which is your data, and header properties, right? The first thing you can filter on is the header properties. Oh, let me actually move ahead, not backwards. The first thing you can actually filter on, is tags, before even the content of the message. You can actually filter the messages when they arrive and say, based on the twin tags, I'm going to put them here or there. Like if you want all your data coming from building 43 to go in one storage blob, and all the data from building 42 going to another storage blob, super easy with routes. The other thing is message property. For each of the messages, when there's a new message arriving in IoT Hub, it will look at the properties. If the properties matches the rule, boom, it sends to that endpoint. And now, recently we added the possibility to do the filtering on the data which is in the body. So you have to indicate the content type and the content encoding so that actually knows how to read the content. So usually we support JSON today with UTF-8 1632 encoding. So you pick your choice here, and when the message will have the property that you set in your rule, then it will be sent to a specific endpoint. Okay? So let's try and do that. And we'll see if we are successful. So let me actually stop this guy here. I don't need it. And for now, I don't need this guy either. And I have this device twin here that we'll see later. Let me go to my portal that I closed because I went too fast. And I'm going to open that IoT Hub, and I'm going to set up a new route for a new endpoint. So my IoT Hub is this guy here. And what I will need is, let's go with an event hub, for example. So what I'm going to do, I already have a namespace. It's going to be faster. I'm going to create a new event hub into that namespace. Come on. It's loading. OK, let's go back. Let's go and do it. That's OK. Get off the web, people. What's going on? Where's my event hub here? This guy. Actually, I was not in the right place. Let's create a new event hub. And it's going to be my alerts, for example. So that new event hub will be addressable from IoT Hub as a new custom endpoint. I'm going back to my resource group. I pick my IoT Hub. And in the IoT Hub blade, all the way down here, I have endpoints. And it has no custom endpoint for now, because I have a subscription with some limits, because they told me to stop spending money. I don't know why. So I can only create one endpoint. I will say Event Hub in there. I will pick the namespace that was, what was the namespace, people? That was this one. Ignite demo, Event Hub sync, and my alerts is the one I just created. OK. And from there, what I want to do is, let's look at a code sample coming from this guy here. And in here, we have the simple device sample, and see what it's sending. So it's sending this kind of data, so device ID, wind speed, temperature, and it has a property when the temperature is going to be above 28, that is temperature alert. So that seems to be a good thing to look at in my route. And what I will do is in here, once the endpoint is created, I'll be able to go ahead and create a new route. So the route itself will ask me what kind of, I'll do that, alert route. The data source has to be, in that case, the device messages, because I will look at the properties of the message. And I will send that to the newly created custom endpoint, which is my alerts. And here, what I can do is simply type temperature alert, was that the name? And equals, and I will say true. That's the one I want to test. Let me just double check that. Temperature alert equals true. OK, sounds about right. And because actually I want to make sure that I'm not doing something stupid, I'm going to do that. I'm going to test that immediately. And I'm going to say true and see if it works. I'm going to run that rule to see if it works, result match, and basically if it's false in the message, so that's a fake message here, and so I can test, so false unmatch. So basically my route works. In theory, any message that has the property header temperature alert should be sent to that event hub. So what we're going to do is we're going to start the device. And it's here. Oops. And that's the sample device here. It's running, sending data. And now we'll do something with that data. So it's in an event hub. There are ways to monitor an event hub, but I think it's funnier to do something with that data coming into event hub. And that's the risky part, because I've not tested that yet. Let's create a new logic apps. That's going to be easier. I'm going to use logic apps to get the event from the event hub, and then I'm going to try and tweet when the alert message has been received. Logic apps is the new service I'm going to add. Have you played with logic app, anyone? Have you played with if this then that? No, yes? That's the same, but for enterprise. Logic apps. Create a new one. You'll see there's a designer that's going to come up. You need to find fancy names. It goes into the same resource group, so I can delete all my demos at once. I don't know if you're playing with resource groups, but that's really a nice tool. And now it's creating that logic app resource. Let me go back here. It's going to take a second or two or more. We'll see. Oh, there you go. Pretty fast. It's pretty amazing. And what was the name I chose? It was this guy here. No. My new logic app. Logic. The designer starts, and basically, logic apps is a really nice way to do proof of concept, but also to implement actual solution using IoT stuff, right? There are some samples of things you can do. I'm going to try with a blank one, and I'll pick a trigger for that logic app. So the trigger would be an event hub, logical. So I'm going to pick the event hub. I'm going to configure that trigger. Here we go. That's the one. When events are available, do something. And basically, it's already picked the right one. Perfect. And every 1 minute, I'm going to try and see if, well, actually, that's not the right one. Let's do that. I did create a new namespace. This is where I need you to follow. What was the name of that new Event Hub namespace? You know what? If you help me, I can give you one of the boards here. So what was the name of the Event Hub namespace? Sorry? I don't remember. There was an alert in there. Let's try and find. It doesn't search. Tell me when you see it. Oh, this one. That was this one? Okay. And so that's fine. It's already in there. Blah, blah, blah. Create. I don't know if someone actually told me that. And it was my, I have the right one already. I'm going to keep the board, sorry, guys. Okay, and so every minute I'm going to do something. And that something will be an action. An action actually will be Twitter. So I'm going to pick the Twitter connector, and I'm going to post a tweet each time there's something new that appears there. And text to be posted. Oops. Temperature is out of control here. Okay. And I have a connection because I already connected Logic App to my Twitter demo account. And so basically, I can say save. And with a little bit of luck, when we're going to have everything triggered at some point, we're going to have a new tweet that's going to land in here. And I'll get back to it later, because it's not that I don't trust Logic Apps in terms of reactivity and when it's going to go live, but that's something we can come back to later. OK, so you've seen like a few clicks. I was able to create a set of services that were actually acting based on events for taking actions. There's a filtering with the routes. There is the event hub to pass on the data at a very high throughput to another service. And there's Logic App in the back that will trigger something that is more high level. So these are examples of what could be done. And what I want to do eventually is show you some more. So we have some basics about how to get started. And there's a link for that, which is basically Azure IoT Get Started after ak.ms. So once you've played around with the basics of connecting a device, then you can play around with creating something. So the one with Streamlytics and Power BI allows you to see in real time what's going on from your device when you send JSON data. Pretty straightforward. You have the notion of a web app, because maybe you just want to do everything manually in the back. You can leverage Azure Functions. You can leverage machine learning through an API call from Streamlytics. Actually, that's a weather station sample there, where you have devices sending temperature, humidity, and then you have anomaly detection that is done through a single API call to cognitive services to determine the trend of your temperature. So these are pretty cool samples that you can just go and play around with. I want to show you another of these projects that go along with the little board I have here. Let me see if this arrived already. If not, oops, hey, you see Twitter. Yes. And I promise I don't have an assistant in the back sending a tweet. It was really the guy up there. And actually, the interesting thing is that you can go back here, because I know you guys are skeptical. I can actually go and check out my new Logic App. and see the logs of when it's been triggered. So you see every minute here, or actually more often. Is that the right one? My new logic app? Yeah, it's been triggered a lot. I might have put 1 second, so it's actually all the time trying to see what's going on. And it did fire some tweets, so I'm going to receive a sea of tweets up there. And logic app will shut down because it will say, yeah, you didn't pay that much. So basically, you can then track what happened in there. Well, the portal gives you a nice view, but then you also have Azure monitoring that actually will allow you to monitor several services together, including Azure IoT Hub at some point. Okay. So the starter kit that we have here, the MX chip board, some people already had one because they came to the pre-day session. They are back-ordered because of the success, but they should be in stock soon, and they cost $35. They have a bunch of sensors. You can play around with them. We have other starter kits if you want, but these ones are pretty cool. And they have a set of projects that you can implement very easily with few clicks, and some of them have really cool scenarios. I'm going to show the dev kit translator here, and that's going to be my last demo of the day. So hopefully it works, because the rest was not too bad. Let me actually kill this guy here. I don't want any more alerts. And I'm going to open the project for this little board here. And it's called dev kit translator. And here you go. So what I'm going to do is I'm going to deploy on the device. What it does, it basically talks to IoT Hub. Through a function, it will ping and pass over, the data of my voice has been recorded on the device. It will ping cognitive services to translate into another language, and it will send back to the device to display on the little screen. Right? So I will have a portable translator running on this tiny device, and you can deploy that same solution yourself. It's pretty straightforward. Let me deploy on the board. Let me bring this little guy here back so you see what's going on. And I just hope that everything just boots and works. So I'm going to talk in French to this little board, and it should answer in English. What's going on right here in VS Code is we're leveraging one of the extensions, which is the Arduino extension that we developed, that allows you to have all the interaction with Arduino code, sketch, and hardware from VS Code. So you can reuse your existing sketches if you're an Arduino developer, but then you can leverage all the intelligence and richness of VS Code using that extension. And because we have the other tools for Azure IoT Toolkit and others, then you have one experience, one IDE, which is cross-platform. So if you're on a Mac, exact same experience. If you're on Linux, exact same experience. So that's pretty cool. And it seems the device is now online. And it's telling me to talk Chinese. So no, because I don't know Chinese. So that's a default language. And there is Chinese, Arabic, French. Basically, the cognitive services APIs know tons of languages. So this time I'm going to pick French, and I'm going to hold B to talk to it. And I'm going to say something everyone can recognize. Bonjour. I'm French. So uploading, hoping, praying, receiving. Hello. So the tiny device can translate French. Woo! Okay. Good. I think we are right on time. And I think right now what I want to do is point you to one URL here for starter kits, where you can find resources for hardware like this one. And the other one I want to invite you to look at is the next one, which is this, Training for Azure IoT. What I just presented is a glimpse. I really wanted to introduce the principles of IoT Hub. I hope it was clear what IoT Hub is for and how to interact with it. But then if you want to go in depth, we have all these trainings available by third parties or by ourselves with online training that you can get more information about Azure IoT, get trained. We don't have a certified program yet, but that should come soon. So you should be able to become an expert on Azure IoT stuff. I will be on the booth for the rest of the day almost. So if you want to find me and ask more questions, that would be great. If you have a few questions, then we have 5 more minutes that you can shoot some questions. Yes? Can you say that again? Can you, sorry, I don't hear you.
So the automatic device registry
yes.
in Azure, what is the typical cost of that? Is it based per device or is it per month?
Oh, the cost of, so the registry itself is part of IoT Hub. And so what you pay is IoT Hub per SKU. So we have a free SKU that has a limit in terms of number of messages you can send. You can only have one free SKU and number of messages per day, basically. So I think it's 4,000 messages per day on the free SKU. You don't have limits on number of devices, so no limits on the device registry for any of the IoT Hub. And then for the various SKUs, you, once again, don't have a limit on the number of devices. What the limit is on the number of messages per day and number of operations. And so we have a very nice table that explains for each SKUs, and we have notion of units that actually tell you what kind of limits you have. Right? Within one SKU, you can multiply the number of units of your IoT Hub. So one instance of IoT Hub in S1, you can have up to 100 units. Each of the units basically increase your capabilities or your threshold numbers. So I invite you to go to the documentation. There's like a very comprehensive table of all the pricing and all the limits for all the operations in all directions. If you think about it and you're looking at, hey, that model with SKUs compared to the pay-per-use, IoT Hub is very rapidly more cheap, I would say, or cheaper, when you come to volumes that increase compared to big competitors, where they have a model which is pay-per-use. So it's fine when you're having lower volumes, but as soon as you pass some numbers, your price still goes up. Ours stays the same because we have this notion of SKUs and limits. So you have a better control over the cost because you can actually have this kind of you don't have the surprise. And you can also prepare for a spike in use, because if you have a spike of one event, for example, you're organizing, and suddenly you're going to have 1 million devices starting talking every second, you can increase number of units during the day, and when you're finished, you just decrease that number of units, and you're in control of your IoT Hub cost. Makes sense? Yes? So the question is, does IoT Hub store the messages from devices? The telemetry messages, yes. Basically, there's an event hub under the hood that IoT Hub will retain the messages from devices into with a retention policy. And by default, the retention policy is 1 day, and I think you can increase up to 7 days, and that's a feature of Event Hub. And basically, IoT Hub benefits from that feature, out of the box. It doesn't work for twins, though. Device twins is just last known state, and you have a size of twin which is limited per device, so you cannot also put whatever you want in there. I don't remember the exact limit, but it's kilobytes. So twins is really for configuration, not for data. Yes? The question is, can you get real-time visualization of your data? Short answer is yes, you can. Power BI now has Power BI embedded, that actually you can have it refresh automatically, and the data is flowing from devices to IoT Hub, is available in that Event Hub endpoint, unless you set a route to send it to another endpoint, and Power BI will feed from that. So the best way actually to do that, the simplest way, we have one of the samples where you have, let me actually rewind a little for that one. You have this guy here, which, this one here, can I write in there? No, I can't, never mind. So you have this one with Power BI, the yellow one. So you put a Stream Analytics job just behind IoT Hub. So you trigger the Stream Analytics job, and Stream Analytics job will say, select star, into the output, and the output is a data set for Power BI. That's the simplest way to do that. Other question? Oh, down there.
You didn't really talk much about IoT Edge. I was wondering, where did IoT Edge come into the picture?
Yeah, so I didn't cover IoT Edge because I talked about it during 1 hour yesterday. So we have a recording for that session. And IoT Edge is an extension to IoT Hub. IoT Hub is the PaaS service running in the cloud. IoT Edge is a runtime that you will be able to run on devices to manage software entities we call modules. IoT Edge will be a device managed by IoT Hub. It will be a super device, if you will, right? That will be managed by IoT Hub. And IoT Hub, we are adding the features to configure an IoT Edge device, configure its modules, its configuration, and so forth. So basically, IoT Edge is a new super device that you'll be able to leverage in the context of IoT Hub. Okay, so we are out of time. I'll be at the booth for questions. Thank you very much. Fill the evaluation, and see you soon.